The lecture is about fluid mechanics. In this video lecture, we are going to briefly discuss about problems on viscosity. Problems on viscosity. In this problem, we are going to discuss the plates are placed in vertical condition. A vertical gap 4.4 centimeter wide of infinite extent contains a fluid viscosity of 4 Newton second per meter square and specific gravity as 0.9. A metallic plate of 2.4 into 2.4 into zero point 0.4 centimeter is lifted with a constant velocity of 0.3 meter per second through the gap. If the plate is at the middle of the gap, find the force required to lift the plate, and the weight of the plate is 40 Newton. See, in your previous problem and all, we will be having only your area, your thickness of your plate will not be available. Whereas over here, the thickness of the moving plate is being given. The first thing you have to note down. Given, they are given your mu is equal to 4 Newton second per meter square. Specific gravity S is equal to 0.9. We know that area A1, A2. Here we are going to only multiply your length and breadth, not your thickness. Therefore, it will be 2.4 into 10 to the power minus 2 into 2.4 into 10 to the power minus 2. They are given your velocity as 0.3 meter per second. First, we are going to draw the diagram. We have two fixed plates on a vertical condition. In between, we have a moving plate of 0.4 centimeter. They are given the gap between your two fixed plates is 4.4 centimeter. So, subtracting the thickness of your moving plate, we get your dy1 as 2 centimeter and dy2 as 2 centimeter. First, we are going to calculate volume of plate. Volume of moving plate V is equal to length into breadth into thickness of moving plate. Substituting your L length as 2.4 into 10 to the power minus 2 into 2.4 into 10 to the power minus 2 and zero point 0.4 into 10 to the power minus 2. We get volume V is equal to 2.304 into 10 to the power minus 6 meter cube. Next, we are going to calculate your shear stress. We know that tau is equal to mu into du by dy. Therefore, tau1 is equal to mu into du by dy1. Substituting the mu, du and dy value, we get tau1 is equal to 60 Newton per meter square. Since dy1 is equal to dy2, therefore, we know that tau1 is equal to tau2. Therefore, shear stress tau2 is equal to 60 Newton per meter square. Force. The formula for finding your force is tau1 is equal to F1 by A. We know that tau1 as 60 and your A as 2.4 into 10 to the power minus 2 into 2.4 into 10 to the power minus 2. Therefore, F1 is equal to 0.03456 Newton. Since dy1 is equal to dy2, we know that F1 is equal to F2. Force F1 equal to F2 is equal to 0.03456 Newton. Therefore, the total drag force F is equal to F1 plus F2. Substituting your values, we get the total drag force as 0.06912 Newton. Since the plate moves vertically in upward direction, first we are going to calculate the upward thrust. Upward thrust is equal to density of liquid into volume of fluid displaced. First we are going to calculate density of your liquid from specific gravity. We know that S is equal to density of liquid divided by density of standard liquid. Substituting the value of S and density of your standard liquid, we get density of your liquid as 900 kg per meter cube. Substituting the value over the above equation, we get upward thrust is equal to 900 into 9.81 into 2.304 into 10 to the power minus 6. Over here, 900 is your density and your 2.304 into 10 to the power minus 6 is volume. This 9.81 has been used over here in order to convert this kg into Newton. Therefore, upward thrust is equal to 0.0203 Newton. Next, we are going to calculate net force acting towards downward direction. Net force is equal to weight of the plate minus upward thrust. We know that the weight of the plate is given on your problem as 40 Newton. Substituting your upward thrust over here, we get net force is equal to 39.97 Newton. The last step, total force required to lift the plate. Total force is equal to drag force plus net force acting towards your downward direction. We have calculated your drag force as 0.06912 and your net force as 39.97. Substituting over here, we get the total force as 40.0391 Newton. Note, when the plate moves in downward direction, then the net force formula changes to weight of the plate plus downward thrust. Over here, since it moves on your upward direction, here we are going to say weight of the plate minus upward thrust. If it moves towards downward direction, then net force is equal to weight of the plate plus downward thrust.